On Universe Unlocked tonight, we ask a question so reckless it feels forbidden. What really happens if we nuke the moon?
Does the moon explode into deadly fragments, knocking Earth's climate into chaos? Or does our closest neighbor barely notice the blast?
Before we answer, we need to remember what the moon actually is, and how dangerously dependent we are on it.
Over 4.5 billion years ago, a Mars-sized world we call Theia slammed into the infant Earth in a cataclysmic impact. Debris from that collision reassembled into our moon, turning a moment of destruction into the beginning of a long cosmic partnership. Since then, the Earth-Moon system has shaped tides, seasons, and maybe even the long-term stability life needed to flourish. The moon's gravity pulls on our oceans, creating tides that sculpt coastlines, stir nutrients, and set the rhythm for marine life.
Those tides are not just scenery. They help mix oceans, influence weather patterns, and have guided life for billions of years. The moon also helps stabilize Earth's axial tilt, keeping our climate from lurching between extreme, chaotic states.
Without that stabilizing partner, our seasons and ice ages could be far more violent, making complex life much harder.
So when we talk about nuking the moon, we're not just talking about a rock in space. We're talking about attacking part of Earth's life support system.
Shockingly, during the Cold War, the idea of detonating a nuclear weapon on the moon wasn't just fantasy. It was a classified study.
In 1958, the US Air Force explored Project A119, a plan to set off a nuke on the lunar surface as a show of power. The flash might have been just barely visible from Earth, a terrifying advertisement of nuclear capability written across the night sky. That visual never became reality. Today, the Outer Space Treaty explicitly forbids placing nuclear weapons on the moon or any other celestial body.
International law now demands that the moon be used for peaceful purposes only. No weapons tests.
But as a thought experiment, we can still ask, if we somehow broke those rules and detonated a bomb there, what would the physics say? Start with the strongest nuclear weapon ever tested, the Soviet Tsar Bomba, with a yield around 50 megatons of TNT.
That blast released about 10 to the 17th joules of energy. That's a difference of billions.
Detonating one bomb on the moon is like heating a pinprick on a bowling ball. Dramatic locally, but the ball stays whole.
So let's imagine a single, powerful thermonuclear balloon device.
For a few blinding moments, the explosion outshines everything, a hemisphere of plasma flashing against the dark.
But there's no towering mushroom cloud. Without air, the fireball expands differently, hugging the surface and launching dust into space.
Rock near ground zero melts, vaporizes, and is thrown outward. Some ejecta falls back.
Excellence. The immediate result is a new crater, some glassy melt, and a dust halo. Just another scar on Earth, the atmosphere shapes the iconic mushroom cloud. On the moon, you get stark light, shock through rock, and ballistic debris.
An orbiter above would see a dazzling flash and a cloud of ejecta, then a settling dust halo.
From Earth, if you knew where to look, you might see a brief, unnatural twinkle on the moon's edge. Then, nothing.
The radiation burst would spread in all directions, but at nearly 400,000 kilometers away, Earth gets a faint whisper, not a lethal dose.
Radiation intensity falls off with the square of distance. By the time it reaches us, it's lost in the background of cosmic rays and solar particles.
And the moon's orbit? Essentially unchanged. One bomb can't noticeably slow, speed up, or knock that massive body off course.
The moon's orbital energy is around 10 to the 28th joules.
Some ejecta would go into new orbits. A tiny fraction might eventually drift inward as micrometeorites, but nothing like a catastrophic storm of rocks. Most of the debris simply falls back down, adding to the moon's already dusty, well-cratered face.
Compared to the enormous impacts the moon has already survived, one human-made crater is just one more scar among millions. But what if we went much further and somehow shipped most of Earth's nuclear arsenal to the moon? Could we blow it apart then?
Even if you combined all known warheads, their total energy is still thousands of times too small to fully unbind the moon's gravity. You might dig huge, overlapping craters, vaporize vast areas of rock, but the moon... Hollywood loves a shattered moon raining fire on Earth. Real physics says, not with anything we can reasonably build.
A truly massive impactor, not a bomb.
Even then, our atmosphere is a powerful shield. Most smaller fragments would burn up as meteors long before reaching the ground.
If, hypothetically, we somehow chipped away a noticeable fraction of the moon's mass, tides would weaken.
Over very long timescales, a lighter or missing moon could mean a less stable tilt and more extreme swings in climate.
So the immediate, realistic result of nuking the moon isn't planetary apocalypse. It's a radioactive scar on a world we may one day try to live on.
Future lunar habitats would want to avoid contaminated regions. Every crater we create carelessly makes the moon a little less friendly for exploration.
That's part of why space law forbids nuclear weapons on the moon. It's not just about war, it's about protecting our future outposts and science.
The Outer Space Treaty makes it illegal to install or test weapons of mass destruction on the moon or anywhere else in space.
It's one of humanity's few truly global agreements. Space, and especially the moon, should remain a domain.
On Universe Unlocked, we love dark what-if questions like this, but we also respect the real physics and the real ethics behind them.
We saw how Project A119 almost put a nuke on the moon. How massive our bombs are.
We learned that gravitational binding energy locks the moon together, and distance shields Earth from...
We also remembered why the moon matters. Tides, tilt, climate rhythms, even the timing cues many species...
Take the moon away entirely, and our planet becomes more unpredictable. Not uninhabitable, but a lot less comfortable for complex life and civilization. Imagine explaining to future generations living on the moon why we once thought it was clever to scar it with nuclear fire.
Asking, what if we nuke the moon, is a great way to learn physics, and a terrible way to plan real missions.
The Earth-Moon system is not a toy. It's a fragile, ancient balance that we are only beginning to understand, let alone protect.
In a galaxy filled with worlds, our double-planet moon dance might be rare.
Our technology now lets us change worlds faster than we can fully model the consequences, especially beyond our atmosphere.
But we also have the power to decide what kind of spacefaring species we'll be. Reckless or careful, curious and wise.
On this channel, every video is a journey through ancient Earth, deep space, weird physics.
If you like this kind of grounded but mind-bending what if, you'll love our dives into asteroid deflection, megastructures, and more.
Subscribe to Universe Unlocked so you don't miss the moment we turn the next wild headline into an understandable journey through real science.
And tell us in the comments, do you think there is any scenario where nuclear explosions in space are acceptable? Or should that line never be crossed?
Real experts still debate how to balance planetary defense, nuclear technology, and space law.
In our thought experiment, we can always rewind. In reality, one bad decision could leave scars that last for millions of years.
The Apollo astronauts called Earth a fragile oasis in a cosmic dark. The same is true of the moon.
Maybe our first rule for the rest of the solar system should be simple. Explore boldly, but do as little harm as possible.
The moon has watched over life on Earth since before the first forests grew, before eyes even evolved to see it.
For countless generations, it has been a clock, a compass, a storybook, and a mirror for our imagination.
Nukes, treaties, equations, they're all part of our modern story.
So if we ever reach the point where we can do something as drastic as nuking a moon, we need the wisdom to decide not to.
Our mission at Universe Unlocked is simple: to use real science and powerful storytelling. Tonight, that meant understanding where the moon came from, what it does for us, why nukes can't destroy it.
There are entire galaxies out there that will never notice whether we treat our moon with care or with violence.
But for us, here and now, the difference is everything.
This is Universe Unlocked. Thank you for daring to ask dark questions and for caring enough about the answers